All right, I wanted to give everybody an example of Hardy-Weinberg just to make sure that you understand how to do the 5 steps of the problem. In this example, in our population that's always 100, 9 butterflies are showing the recessive trait for translucent wings. So the first thing we want to do is write the 2 equations so we can refer to them and make sure our math is correct. We have p squared plus 2pq plus q squared equals 1. In here, p squared is going to be the homozygous dominant individuals. 2pq is everyone who is heterozygous, and q squared is everyone who's homozygous recessive. Now, instead of looking at the population only as butterflies or only as individuals, we want to also look at it as a cumulative gene pool, meaning every allele present. The second equation does this. P by itself is the dominant allele. Q by itself is the recessive allele. So our very first step is always going to be to identify Q squared. The reason is the Q squared are the homozygous recessives. We are looking at a recessive trait. You only physically see a recessive trait if the individual is homozygous recessive. There is a recessive right here, but it's being covered by a dominant allele, so therefore these two things would not show the recessive trait. So Q squared is going to be however many you have in the population divided by your population. So 9 out of 100, that is 0.09. We can go ahead and kind of plug this in up here, and that way we can kind of check our progress. The second step is the most important. We want to go from the actual butterfly to just the recessive allele. The way we do this is to take the square root of Q squared. That gets rid of that little square right there. So the square root of 0.09. Please use a calculator so you don't miss any points on the math. That is 0.30. That means 30% is the frequency of the recessive allele. We see the allele 30% in this population. Step 3, I know that my P and my Q together have to equal 100. If Q is 30, that means P has to equal 70. So you have a little math check. 70 and 30 is 100, and you are correct. Now that I have my gene pool alleles, I can plug them back in to figure out how many are completely dominant and how many are heterozygous carriers. So I take my P that is 70, and I'm going to square it, which means 70 times 0.70, which is 0.49. That means my P squared is 49%. Now, I don't really like algebra, so I don't want to plug in just personally all of these variables. You can if you want. I like to use logic. These 3 things have to equal $1. So let's say in one pocket you find 49 cents. Another pocket you find 9 cents. That's a total of 58 cents you have. How much more money do you need to get to that $1? You would need 42 cents, and that is your final total here. Now on your homework, you would then plug in these where they belong. So let's say you are looking for the frequency of a homozygous dominant trait, so 2 capitals. You know this is homozygous dominant. You would therefore say it is 0.49 or 49%. If you just have one capital letter, just one on its own, is the allele. So the dominant allele would be 70%. The recessive allele, one letter on its own, would be 30%. This would be your heterozygous, and this would be your homozygous recessive. Hope that helps.